Hello everyone, welcome to this lecture video. In this lecture video, we will discuss the March storage system in the operating system. It comes under the IO systems. How the March storage system helping in the operating system to have the without have the process in the without any deadlocks and the smooth running of the process. So in the mass storage system we have the disk structure. In this topic we are going to discuss disk scheduling, disk management, how the swap space management, RAID structure, disk attachment, stable storage implementation, then territory storage devices, the operating system issues and performance issues. So this mass storage systems we having this disk storage structure. We have the disk drives are addressed as a large on dimensions array of logical blocks, where the logical block is the smallest unit of transfer. We have start with the disk structure. In this first dimensional array of logical blocks is mapped into a two sectors. Sector 0 is the first sector of the first track and the outermost cylinder. Then mapping procedure proceeds in order through the track, then the rest of the track in that cylinder, and then throw the rest of the cylinders from the outermost to the innermost. So this is a disk structure. And then disk scheduling is the operating system is responsible for using hardware efficiency. For the disk drive, this means having a fast access time and a disk bandwidth. So access time have two major components. First one is the seek time and rotational latency. It's the time for disk to move the heads to the cylinder containing the desired sector. Then rotational latency is the additional time waiting for the disk to rotate the desired sector to the disk head. Then minimize seek time. We have the seek time, we seek distance. So disk bandwidth is the total number of bytes transferred divided by the total time between the first request for the service and the completion of the last transfer. So disk scheduling, you have this kind of process. Next, with the disk scheduling, you have for a request from the queue 0 to 199, the head pointer will be 53. For example, 98, 193, 183, 37, 122, 14, 124. These are the values. Here, the several algorithms exist to schedule the service of the disk IO request. So, disk scheduling, how the service, how the several algorithms head up using here. Then illustrate source through total head movement of 640 cylinders. So Q equal to 98, 183, 37, 122, 14, 124, 65, 67. This have the FCFS scheduling will be placed here. Then next is the SSTF. FCFS is the first come, first serve, and things we have. Then SSTF we have to select the request with the minimum seek time from the current head position. And also we have the SSTF is scheduling is form is SJF scheduling may cause starvation of some requests. So illustration shows the total head movement of 236 cylinders. So SSTF we have this kind of process. So form SJF scheduling may cause starvation and other things. So illustration shows 236 cylinders. So SSTF followed with this kind of things using here. So the scan we having the process here. So disk arm starts at the one end of the disk and moves towards the other end, servicing request until it gets to the other end to the disk. Whether the head movement is reserved and servicing continues, sometimes called the elevator algorithm. Illustration shows total head movement of the 208 cylinders. So that is a scan here. So scan we have the graphical C scan also we having. So C scan we having the provides a more uniform wait time to that scan. The head moves from one end to the disk up to other servicing request as it goes. When it reaches the other end, however, it immediately returns to the beginning of the disk. So without servicing any request on the return trip. So C scan provides a more uniform wait time than the scan. So it treats the cylinder as circular. A list the traps around from the last cylinder to the first one. So we having this kind of C scan and other things we having. So next with the graphical picture we are can able to understand the C scan and C look. So these are the different versions of C scan, C look we are seen in this lecture video. So C scan SSTF select the request with the minimum seek time from the current head position. So SG is followed the SGF scheduling. FCFS have the totally plays an important role. We follow 640 sliders. So hope you all listened about disk scheduling and disk structure in the mass storage systems. In this video, we are discussed these disk structure, disk scheduling, disk management, and how these kind of things helping in the IO systems for the operating system. Thanks for watching. We can see in the next video.